what I'm talking about.
All right.
Max isn't fun.
Okay, so here's what we're going to write.
Only kills 99.9%.
Okay. So you wrote organic compounds must contain carbon. Next thing you're going to write, organic compounds have weak forces of attraction. Weak forces of attraction. That means they have low boiling points. That means they evaporate easily. All the things we just talked about back there. So that means it's volatile. That's what that means. Volatile doesn't mean dangerous, but most dangerous liquids are volatile. So, but it doesn't mean dangerous. It means evaporates easily. So weak force of attraction, low boiling point, evaporate easily. Thing we didn't talk about back there. What type of bonding has the weakest forces of attraction? You got 5 types of bonds: ionic, polar covalent, non-polar covalent, metallic, network solid. Out of those 5, which one is the weakest? Anyone remember?
You say them again?
Yeah, ionic, non-polar covalent, polar covalent, metallic, network solid.
Is it non-polar covalent?
Very good. Non-polar is basically the entire, all organics are basically non-polar. So weak forces of attraction, that's the type of bonding we're talking about, is non-polar covalent bonds. Non-polar covalence. In general, so all that stuff back there, they were wafting non-polar bonding. What's the weakest force of attraction?
Hydrogen bond.
Dispersion forces, very good. So next to this,
I always forget about that.
Dispersion forces, good.
I have no room for that.
So dispersion forces. Forgetting one thing. Just drew a blank there. Oh, okay. Once you get that down, I'm going to write a list of, I got boiling points up here. Oh, just for your knowledge here. The methanol boils at 64.7, ethanol at 78.4, acetone at 56, isopropyl alcohol 82.6. All of them are lower than water, which is 100. So I just wanted to prove it. Those are actual numbers. So again, they're weaker forces, therefore they boil at lower temps. Write these down, please. What do we got? We got methane. We got, write them in a list underneath each other here. Methane. We got propane. We got butane.
Do we need to like save room for them?
No, you can do each line. And octane. And then if you have room up here, hopefully write BP. So I'm going to give you the boiling point of all 4, and you're going to tell me what the trend is. Okay? Okay, methane boils at negative 161.5 degrees. Propane boils at negative 42 degrees Celsius. Butane boils at negative 1, and octane boils at 125 degrees Celsius. So the reason Zach was saying for some reason, he put gas on a rock and lit it on fire. But the reason he said it burns for a long time is the same reason it has a high boiling point. So we'll talk about that in a second. So write that down and then tell me, using tables P, mostly table P, what's the trend here? Don't say it out loud. What's the trend? And then I'm going to have someone come up here and draw a graph for me. So sketch this graph somewhere. I'm not going to fill it in yet because I want to first see if someone comes up with it on their own.
That's really big.
No, it can be small. Just big enough so you can write on it. It can be big, small, whatever floats your boat, whatever knocks your socks off, or blows your hair back. Whatever tickles your fancy. Can't think of anything else right now.
John, drink wine.
All right, what's the trend here? Go ahead.
As the more carbon there is, the higher the boiling point.
Yes. More carbons, the higher the boiling point. So number of carbons goes on the X. Boiling point on the Y. I'll just draw it, but someone tell me. Raise your hand and tell me. What's the graph look like? I'm just being a jerk. Good job, Shelby. Direct relationship. Good job. Yes. As the number of carbons goes up, the boiling point goes up. So, Nicole, If I was to write decane here, would we expect it to be above 125? Yes. Good. Now, why is octane so high?
Because it has more to boil. Like it has more atoms.
Good. It also has more. What's the
Forces
only
of
thing that
attraction.
dictates boiling point?
Force of attraction.
Force of attraction. So this has more. Is that what you just said?
Yes.
You didn't say a
Good
lot
job.
about
You did it to me.
More forces of attraction. Very good. So what we're going to write here, actually, hold on. I get excited about this because it explains everything we've already learned. What's the weakest force called again?
London dispersion force.
Dispersion forces. Now, everybody look over on the side here. Taylor, you're going to help me out here.
Oh, look at
Just
that.
leave it.
I was
Taylor, how many electrons does helium have?
2.
2. How many electrons does radon have? 86. Good. How many electrons does fluorine have?
9.
How many electrons does AT have?
85.
85. Good. So as we move down these groups, Taylor, does the amount of electrons go up? Yes. Also, keep looking. As we move down these groups, the dispersion forces increase. So radon here at the bottom has a much higher boiling point than helium, and acetine has a much higher boiling point than fluorine. So as we move down, their boiling points go up because their dispersion forces go up. What does that analogy there have to do with what's on the board? So yeah, we get this. Number of carbon atoms increase, boiling point increases. But what does what I just said there have to do with that? That's what we're going to write. Because it's easy to say, okay, as the number of carbon atoms increases, boiling point goes up. That's easy to explain and see. What's really the reasoning behind it? Explain.
More electrons.
That's just 2 words. I don't think everyone understands what that
They
means.
have more electrons, so they have a higher boiling point.
Why?
Because there's more substance.
I'll give you a little help. What causes or creates dispersion forces? Anyone remember? Electron movement. So now finish. As you move down, more electrons. As you move down, more electrons. In case you're not following, how many electrons does methane have?
4. 3. Wait, what?
1.
How many electrons does each hydrogen have?
They each have 1.
1. So 1, 2, 3, 4. 4 from the hydrogens.
And
How
then-
many here?
6.
6.
So 10.
10 electrons. How would we count up the number of electrons here? It would be 1, 2, 3, 4, 5, 6 plus
12.
6 plus 6.
18.
18. So this has 10, this has 18.
Then it-
This has a higher boiling point than this. Why, Edmund? Don't just say because it has more electrons.
Because it's larger.
It's larger, so it has more electrons, and if it has more electrons, then it has more of this.
And stronger forces.
Give me the name.
Stronger dispersion forces.
Right, but we got to put it all together. Very good. So more electrons means more electrons moving. If there's more electrons moving, there's more dispersion forces. If there's more dispersion forces, it's harder to boil. That's essentially what we're going to write. That's the real explanation for why the boiling point goes up. So I'll try and summarize it here. So as the number, oops, I'll use a number sign here. As the number of carbons increases, the number of electrons increases, resulting in more, or not more, let's say, yeah, we can say more, resulting in more dispersion forces. So water boils at 100 degrees. Octane boils at 125. That goes against everything we've already learned this year. We've learned polar is stronger than nonpolar. Water, H2O, is polar, but it boils at 100. So this is disproving what we learned earlier. That's the problem with chemistry. We teach like kind of black and white. We learn black and white. It's easier for our brains to understand that. But there's a lot of gray area, meaning if there's enough of the dispersion forces, it can actually make it stronger than the polar. So I'm not telling you that to confuse you. I'm just telling you that because I need to explain it. All right. So in general, polar is stronger than nonpolar, but there are exceptions to that rule. So this is kind of a big thing. The regents hammers this sometimes. They ask a lot of questions about boiling point and forces, and specifically this. So as the number of carbons goes up, boiling point goes up. Okay, so that was the gist of it. That was what I was trying to get you to understand today. And I've said the term forces of attraction a lot, so hopefully it's sinking in there. All right. So I know we only have a couple minutes left. I'm going to quick show you kind of how to do numbers 1, 2, and 3 on the homework, and then that'll be it. All right. So in your notes, write down alkanes. Alkanes are the first group we're going to talk about on table Q. Alkanes are all single bonds. All single bonds. And alkanes are also called saturated. Underline that. I'll explain that tomorrow. I have to teach you the other two at the same time. It's hard to teach it one at a time here. So we'll come back to that. I'm going to draw two structures. I want you to draw them as well. And hopefully we don't get chopped off by the bell. If we do, good luck on the workshop. I'll understand if you have trouble.
Thank you.
Okay, so copy those down. I'm going to show you how to name these real quick. The homework you're going to be drawing, so it's the same but opposite. So I'll give you the name, you draw. Whenever we draw these, you always put carbons in a straight line. Always do that, it just makes it a lot easier. Make sure there's always 4 bonds too. 1, 2, 3, 4 for each carbon because of 4 valence electrons. So real quick, let's try and name this one before the bell. If this has 3 carbons, what's the prefix? Anybody? Pro. And if it's all single bonds, it's an alkane, so it's called propane. A-N-E. So if you're given a structure, that's how you name it. You start with the prefix, then you look and see, okay, what's the ending? A-N-E, E-N-E, or Y-N-E? What about this one? Who can name that one? Start with the prefix. 1, 2, 3, 4 carbons. What's the prefix? But. All single bonds. Butane. So it ends in A-N-E. I gotta stop because I was gonna write. I rushed there at the end, so hopefully that's enough help to give you on the homework there.